The topic is proportionality and ratios, rates, and unit rates. The essential question is, what's the difference between ratios, rates, and unit rates? So what you need to know is that ratios compare terms that are measured in the same units. Ratios compare terms that are measured in the same units. So an example would be, for every 10 pounds of bananas, there are 12 pounds of apples in gift baskets. For every 10 pounds of bananas, there are 12 pounds of apples in gift baskets. Okay, so the key thing right here for ratios is that they're measured in the same units. So what I mean by units is, see how this is pounds and this is pounds? So since it's pounds compared with pounds, that's a ratio. So I'm going to go ahead and write the fraction that is represented by this statement right here. So 10 pounds of bananas for every 12 pounds apples. Okay, and I think in the past you've seen ratios, you know, that are in the same units. They could be written like this, 10 to 12. Okay, but I really do prefer you writing it as a fraction. All right. Okay, the next one is rates. Okay, and rates compare terms that are measured in different units. Okay, so the example could be, she traveled 60 miles in 3 hours. So the key thing with rates is they are in different units. So look at the units here. We've got miles versus hours, okay? So let's go ahead and write the fraction represented by that situation. Distance on the top, time on the bottom. So this would be 60 miles in 3 hours. Okay, so different units are rates. And the third slot is for unit rates. And unit rates compare terms where one of the terms equals 1. Okay, so the example would be, oranges cost 79 cents per pound. So unit rates compare terms where one of the terms equals 1. And if you're looking on here, you don't really see the number 1. But what's implied by per pound is that's for every 1 pound, it's 79 cents. Okay, so when you see per whatever unit is, that means per every one of that unit. So per every 1 pound, the oranges cost 79 cents for every 1 pound. Okay, so let's go ahead and write the fraction represented by this. So money in the numerator and label it 79 cents per pound. Okay, or I could have used LB for pound, same thing. For your summary, I want you to answer these questions. How do you know if it's a ratio? If you don't remember, reread what you wrote up there. How do you know if it's a rate? How do you know if it's a unit rate? All right, on the back page, we want to write the word proportionality. Okay, and that's when two terms are proportional, they'll change in size by the same rate, ratio, or unit rate. So when two terms are proportional, they will change in size by the same rate, ratio, or unit rate. Okay, so when two terms are proportional, they're showing proportionality. So here's an example that shows proportionality. If you said that the distance you travel is proportional to time, this would mean something like this. If you travel twice as long, you're going to go twice as far. That's a proportional relationship. That shows proportionality. Because distance is proportional to time. Just another example, if you travel 3 times as long, you go 3 times as far. That's another example of a proportional relationship between distance and time. And just a third example. If you travel half as long, you go half as far. That's another example of proportionality between distance and time. Okay, so all these words right here, proportional, proportional relationship, proportionality, proportionate, proportionately, those all mean the same thing. They all mean proportional. So we're just going to circle them. And again, I wanted just you to be familiar with all the words that mean the same thing, okay? Because I don't know how you're going to see it on any assessments in the future. So these all mean the same thing. When you see these words, it means it'd be like a relationship like this, okay? Where the two terms will change in size by the same rate, unit rate, or ratio. Okay, so these relationships right here, I can say they are proportionate. They show a proportional relationship. They show proportionality. For your summary, it's just a yes or no question. I want you to think about it, okay? A person walks half a mile each day. So in 2 days, this person walks 1 mile. In 3 days, this person walks 1.5 miles. Is this an example of a proportional relationship? Think about it. When two terms are proportional, they will change in size by the same rate, ratio, or unit rate. So is this changing in size by the same rate, ratio, or unit rate? Is the distance proportional to the day it is? Right, yes or no? Bye.